Okay, guys, it's Kinesis at it again. So now we are moving over to the hybridization of carbon in ethyne. Now this is ethyne. This is ethyne CH, that is C2H2. This is ethyne C2H2. C2H2, that's ethyne. All right, so this is the structure of ethyne: triple bond and single bond. Okay. Now let us explain the hybridization of carbon before forming this structure. Now, before going further, the shape of this molecule is what? Is linear. The shape is linear, is a linear shape. So the bond angle is what? 180 degrees. That's the bond angle. Okay, that's the distance between the two bonds, 180 degrees. Now let us go deeper. Now this is the orbital representation of carbon, that is before becoming hybridized. Okay, this is it. So this is 1s2, this is 2s2, this is 2p2. Now see what happened. Before carbon forms this bond, that is each of these carbon, before they form bond with each other, they will become hybridized. But the hybridization in this case is what? sp. Okay, sp hybridization. Okay, that is the hybrid orbital is sp, meaning that one electron from this s orbital will be promoted to this 2pz orbital. Remember, this is 2px, this is 2py, this is 2pz. So when this thing happens, now see the orbitals here. They will take this form. Now this is it. So, but after this, after the promotion, the hybrid orbital will be only this s orbital and one of these p orbital, forming this sp. So this is the sp hybrid orbital. Yes. So now this carbon will now form a sigma bond. This bond leads to what? A sigma bond. Okay. So a sigma bond. Look at the bond here. Now, after forming this sigma bond, remember, this is the structure of ethyne. So we need to account for the two bonds, like the nature of the two remaining bonds. Remember that only one is being used. Let me just clean it. Only one is being used in p orbital. That is ps. Do you see? This lies along the x-axis. You know, if you are drawing the three-dimensional axis of the three-dimensional space, you know, x is here, this is x, and this is y. Y is at 90 degrees to x. So this is y, this is x. Do you see why this bond is like this? It is linear along the x-axis, correct? Now, you know, it remains py, that is 2py, and what? 2pz, 2py and 2pz orbital. Okay, this 2p, this is 2pz, and this is 2py, these orbitals. So these are the orbitals. They are unhybridized orbital. Good. Now see what happens now. Two unhybridized orbitals are here in this carbon. Another two unhybridized orbitals are here, each of them containing one electron. Now see what happens now. After the carbon formed the sigma bond, the two unhybridized orbitals will now form a pi bond. They will form two pi bonds. Now let me give you a picture of that. Now this is the plane. This is the two-dimensional plane. Okay? This is the two-dimensional plane. Now this is the C to C bond. This is C to C bond. This is the another single covalent bond that the carbon will form with hydrogen. Okay? Now remember, it remains two unhybridized p orbital, which is py and pz. Good. Now this is p, this is p, Z orbital. This is py orbital of this one. This is pz orbital. This pz orbital. This is py orbital of this one. You know, it is above and below. Okay, above and below. Good. Along this axis. So this is the axis of the hybrid orbital. This one now. These two, this axis now, they are not. They are the axis of unhybridized p orbital. Unhybridized. Good. Now see what happened now. These two orbitals will now form a pi bond. So see the bond here. It will be represented with dotted line, showing that they are weak bond. Okay, you know, it is a collinear overlapping. Do you understand? Sorry, collateral overlapping. Collinear is along the axis of the hybrid orbital. Yes, this one is collateral, that is side bond. Okay, you know how it goes, like this, side bond, like this. Okay, they will form. See the area, the overlapping region. Look at it here. Okay, that is above and below. Remember, always remember it, above and below. Yes, this is it. This is the overlapping region. Correct. So this is it. So this is the both pz orbital of the two carbon atoms. That's what I just showed you here. Okay. If I put all these things here, if I start drawing this electron cloud here, this whole diagram, this whole drawing will look complex. So now, this is the other part of this one. Now, at the same time, this py, these two py will also form pi bond with this one. The two py of this one will form a pi bond with this one. That is collateral overlapping. Okay, there will be a collateral overlapping along the plane. That is 2py and 2py. You understand? 2py of this one, 2py of this one, forming collateral overlapping. And this one, the same thing, forming collateral overlapping. So that accounts for the two pi bonds of this molecule. You understand? So that means that the triple covalent bond between these two carbon atoms consists of what? One sigma bond, that is collinear overlapping, okay, between the two atoms, sigma bond, which is very, very strong, and the two what? Pi bonds, okay, which is the bond, the collateral bond of the what? Unhybridized remaining p orbitals. Good. So this is it. So this is the bonding in ethyne. Okay, this is the bonding in ethyne. You know, I gave only 2pz orbital. So this is the 2py. So this is 2py orbital, like this. You know, the axis is like this. So this is it, above and below, like this. So this is the other one, above and below, like this. Above and below, like this. They overlapped. Okay. So this is the one pi bond, second what? Pi bond. They are weak bonds. So this molecule is, you also know, is a reactive hydrocarbon molecule. Yes, it's reactive because it consists of two weaker pi bonds. Okay. So that is it. So this is it. I hope is very clear. Very, very clear. This is 2py, this is 2py. So this is the hybridization of carbon in ethyne. Yes. So my next video will be on shapes of molecules.